Okay, we'll go ahead and get started. Welcome, everybody, to today's event, To Bin or Not to Bin, How Testing Can Help Design Products That Last Longer. My name is Dave Keating. I'm a journalist based here in Brussels. I'll be guiding us through today's discussions on something that touches both policy and something that we all experience in our daily lives. We know from anecdotal experience that many products just don't seem to last as long as they used to. And it's often more expensive to repair them than to buy a new one. Now, this has given rise to suspicions that companies are purposefully designing products to fail too soon, but actually measuring this phenomenon has been tricky. Whether or not it's by design or by accident, actually measuring how and when this is happening has proven elusive. Now, the European testing project PROMPT has, since 2019, been looking into this. It's been looking at which products are the usual suspects and what causes them to fail. The project has also looked into what would be the best way to assess whether a product is durable or not. It isn't just consumer nuisance that's the problem here. The phenomenon, known as premature obsolescence, also puts considerable strain on planetary resources and households' budgets. It's bad for the environment as well as being bad for consumers. Generation of waste from electrical and electronic equipment has soared in the past decades and is one of the fastest growing waste streams in the EU, growing at 3 to 5% per year and reaching 12 megatons by 2020. The EU is designing rules to make products last longer and become easier to repair. And just earlier this month, we had the European Commission put forward a right to repair law alongside a new law covering environmental claims. So a very current issue in terms of policy and always a current issue in terms of our day-to-day lives. So to get us started, I would like to turn things over to Dimitri Vergne from BEUC, who's going to set the scene for us.
Thank you, Dave. Good morning and welcome to everyone. Thanks for joining us this morning. Well, as you said, Dave, today we'd like to discuss one of the probably most common consumer frustration when it comes to consuming more sustainably, which is the early obsolescence of products. It's probably something that everyone around this room has already experienced or can relate to. Be it a product like household appliances, small electronic, a smartphone, failing earlier than expected, as you said, and being impossible or too costly to repair. So this is, of course, very much annoying, and it puts a strain on consumers' wallets and on planet's resources. Actually, a few years ago, one of our German members, Verbraucherzentrale Bundesverband, showed that consumers could save up to 3.5 billion each year if a handful of common household appliances would last longer. So this shows you the magnitude of the problem. So tackling this issue is really what brought the PROMPT consortium together. And during 4 years, the consortium made of consumer groups, researchers, and also repair specialists looked into really the root causes of this, developed a testing program, and Olaf will tell us about this, and try to understand how products design could really help us to tackle the issue. And today is the final event of this project, and we would like indeed to especially draw policy conclusion about this whole process. And although that's pure luck, I think we couldn't have picked a better moment to do that because the policy agenda is very relevant at the moment on this. You touched upon, Dave, the right to repair proposal last week. We had a very important vote and a positive vote, if I understand well, this morning in the European Parliament, and Ms. Borzan will tell us about this. And we're also in the middle of negotiations on the review of the eco-design framework, which will aim precisely at tackling some of these problems. So there's a lot to discuss, and without further ado, I will give you back the floor, Dave, and I look forward to an interesting discussion.
Thanks a lot, Dimitri. As you mentioned, there are a lot of policy going around. One EU policy that we're all familiar with is GDPR. So I just want to make a quick note that the event is being filmed. In case you don't want to be in the film, you can just sit at the back. That is out of the view of the cameras. So let's hear more about the PROMPT project and what it has revealed about testing premature obsolescence from Olaf Wittler, who is the PROMPT project coordinator and from Fraunhofer IZM in Germany. Olaf?
Yeah, thank you, Dave, for your introduction. So, ladies and gentlemen, thank you for being here and discussing how to make products last longer. My name is Olaf Wittler, and I coordinated the project PROMPT, which was a European project to develop such a kind of test program from the perspective of consumers. And so we had a lot of consumer organizations in our project team from different countries. You will see, oh, sorry. You will see here in the back the partners from the project. So besides the consumer organizations, we had 2 repair companies, and we also had 2 research organizations. So, so we had a wide range of topics to cover in the project. And to start and to get you a little bit into the topic, here's a short video which shows a little bit the problem we want to address with the project. So, yeah, this is something everyone experienced somehow, and we want to avoid this kind of situation. And therefore, we are looking for products which are long-lasting. So also consumers look for products which are long-lasting. And this is not, as you said, not only good for the consumers, not only good for the nerves or the budget, it's also good for the environment, because we need to extract less resources from the earth when products last longer, and we also need less energy to produce the products when we have products which last longer. So the question is now, how do we find these good products, and how do we avoid the products which are bad and not long-lasting? And the challenge in this is that at the point of sale, such an information is not really available. Typically, we have information about price, performance parameters, energy rating, maybe some visual impression. Some things look very valuable and some not. And also we have sometimes information about the reputation of the brand. But information about repairability and longevity is not available. And now the question is, how do we get this information? So, and to get this information, we need some kind of test and some kind of approach to test this. And the question is, to test this, the question is now, how do we need to do it exactly? What needs to be done to do a good product tests? So that's why we did a data collection. So the video which you saw at the beginning, this was a video to get people to give their reports about their problems. And we collected 16,000 consumer reports from across 7 countries in this. And they have been reporting about their problems with the products failing too early, and also reporting about their issues with repair. So the outcome of this is summarized here on the slide. So there were some in the top 5 of the most often reported product. We had the smartphones, printers, washing machines, TVs, and dishwashers. And when we took a closer look in these different product groups, the problems which were observed in the products were limited only to a very limited part of components. So, for example, for the 2,100 reports on the smartphones, more than one half of the failures were dedicated to battery problems, display issues, and software. So, and this example also was observed for the washing machines, for example. Here, nearly 1/3 of the failures were addressed to the electronic controllers and the drum bearings. So this was an important information for us that we can focus on certain aspects in our test program. And when a product is broken, the next step is to get it repaired, to elongate the use phase. So we also had reports about only 1 out of 3 people trying to repair their product after it has been broken. And when asking why they didn't do it, some thought it would be too costly to repair. Others more or less desired a new, more fashionable product. This was the case for more the smartphones and TVs. And sometimes even there were just practical reasons, like missing spare parts, missing repair services, or the product was sometimes not just repairable at all. So the next question is, how do we test for this kind of aspects? So in the first step, we had to focus. There are a lot of product groups on the market, and we focused on 4 product groups, which was the TV and the smartphones on the one side, which represent more the fashion products. And then we focused on vacuum cleaners and washing machines, which represent more a kind of investment good for the people. So we had different categories in our test program to see how this works. And then we tested or we looked for 3 different aspects which were seen as relevant in our examination. The first aspect we all know is about a product which needs to survive different loads during its operation for a sufficiently long time. And this is called reliability. For example, our smartphone, you see in the image, it needs to be able to withstand different drops during its lifetime and shouldn't break it immediately. So this is tested, for example, in a tumble drop test. And there you can, the reliability is tested, for example. The other aspect is the repairability. There you will have to look for how easily is the product to be repaired. You see in this example of the vacuum cleaner that there will be, to repair it, you need to be able to disassemble it, to exchange the part that is broken. So here we need to have a look, how easy is it to disassemble the product in its different aspects. The third aspect is about the consumer behavior. If you look, for example, as this example of a discoloration of a washing machine after UV exposure. When the washing machine gets yellow, this is definitely not a problem for the function. Your clothes will be fine afterwards anyway. So this is no problem at all. But from the consumer perspective, it's changing something in the mental behavior, because they will think my product is getting old, and then they might be less likely to repair the product and to invest into the product to get it longer lasting. So to keep, let's say, to keep the behavior of the consumer in mind was something we also had a look, and we also had a look at what motivated consumers to repair and to keep the products. Because this is also an important aspect which needs to be considered in this. And during this development on all these different tests, we did some general, let's say, experiences. And these general experiences I would like to highlight on 2 examples. The first example is this drop test you already saw. And we simulated here a real-life scenario in the street. So we used as a basement a stone floor, which represents the street. And this is a very demanding test because we did it several times and several times on a stone floor. You would think, oh, doesn't make sense. My phone is not falling so often on the stone floor. But the benefit of such a test is we were able to differentiate. Okay, the products are broken now, but we see some already failed after 50 tumbles, some after 200, and some even survived the 200 sample, the 200 drops. And this gives us an important information about differentiating which product is more robust for harsh use profile and which one not. So this is something we observed also for other test types, and it's important for the consumers to differentiate between less and more durable products. So that's the good part of the story. But there's also a but. The thing is, there are also problems associated with this kind of testing. For example, in the test for the battery life, this is an important aspect. We need a long-lasting battery for our smartphones. And to test this in the test program, we need to charge and discharge these batteries 1,000 times to represent approximately a 5-year duration of use. But the problem is, to do this in the lab takes us 1 year. And to have here a good and realistic test. And you all know, after 1 year, the next model is on the market, so for many consumers, this information about this test is far too late. It doesn't really make much sense to inform the consumer at this point. It's more a kind of experience about the brand policy or something, but it's typically too late. The other aspect is here also the price of such a test. There's a lot of lab equipment needed, a lot of time, and this makes about, just for one model, 4,600 euro. And then you have to buy at least 2 samples, which is again 400 to 2,000 euros. And from these numbers, it becomes obvious we have so many smartphone models on the market, we'll never be able, from the consumer organization perspective or from the market surveillance perspective, to test all models on the market. This will not be possible. Yeah? And so this is our limitation at this point. And nevertheless, despite these examples, we also developed many different test protocols and improved the test protocols in the 3 areas which are highlighted. And here I would like to just point out what we found out. So for the reliability part, we developed test plans to test the batteries more realistically. For the batteries, it's important how you use it and how fast you charge and discharge it. And to consider this in the test program, we developed two different programs to include this. Also, we adapted the known approaches to test the electronics. And so the electronics inside washing machines and TVs was a problem, so we had a look how this works to test the electronics from it. But for the TVs, there was a problem because the TV displays. So just the display of the TV, we didn't find a solution to test the display in regards to its lifetime. It's also technically not really possible to put displays in a kind of certain chamber and test them for a lifetime of 10 years. So this is something we didn't solve. But this has quite typical engineering reasons, because the lifetime is engineered and designed in the product, and this information is from from the consumer organization perspective, this information is not available. This is something which the company somehow did, but of course they didn't disclose how they do this. Yeah? Another thing we analyzed was to have a look at inspection approaches. You see, for example, for the test time, as we said, is very long. And of course, sometimes you can see some design parameters in a product which give a hint about a large robustness. And like, for example, the bearing of a washing machine, there are different construction types. Maybe, so we thought maybe this would be an indicator for good lifetime. Taking a closer look at the design of the products, we also had a look for design criteria which enable the repair more easily or less easily. And in this, to assess the repairability, there are also so-called scoring systems available. So in this scoring system, typically before the project, there was typically the number of steps, for example, counted. How many steps do I need to replace the broken part? The important innovation we did here, we also added the time needed to do this assembly step, because some steps are easy and some sometimes are less easy, and this is a difference in time which needs to be considered, and we introduced here for our scoring system. And the next thing, which was not available before we started the project, was to have a look at the behavioral aspects. So here we had a look, for example, what do consumers need and what is important for them to repair and to maintain a product. For example, supporting a consumer in doing this repair with, for example, fault indicators would help him to keep the product longer. Also to prevent so-called, I call it emotional value losses. For example, to have an enduring, attractive appearance of a product also helps the consumer. And also to support consumers in long use, for example, with support, with guaranteed software support, also helps consumer to keep their products longer and needs to be considered in making this happen. So, doing all these tests, let's say, of course, some things worked, some things didn't work, but the most promising results will be used from the consumer organization in their product testing approaches. But that's not only the only use or dissemination case which is possible with the project results. So the project results can also be distributed into different other activities in the European Union. For example, when we discuss the Eco-Design Directive, we can use the results, and also in national activities, for example, about the repairability index and the outcomes from POMs can be used and can be used for the practical application. So with this, in the end, and we can conclude and summarize the project. What did we find out? We can conclude that we have demonstrated an improved test program and testing protocols, and this enables product comparisons regarding the lifetime of the product. And this approach is based on a relatively comprehensive approach covering different aspects. And this is the good story, and there's also a task for the future, or we call it challenges. The thing is, as I've shown, testing can be highly cost-intensive. And so therefore, on the one hand, a reasonable budget is needed for consumer organizations and the market surveillance, because it costs money. And also, but there's also the problem that standards are sometimes not yet really evolved and available. And also, even if they have a lot of budget available for testing, there's quite a limit because they, as I've shown, they can't test all products on the market. So there's still a limitation. So when we want to make it happen that more data is available to the consumer, we have to tackle two things. On the one hand, we need to inform the consumer in an understandable but still correct way about repairability in lifetime, which is one difficult thing because you see it's complex, this topic, and how you make it possible for consumer to understand this topic at the point of sale. This is one issue. And the other issue is also how do we get the information which is already available? Because we are looking from the outside on the project, and manufacturers, they engineered the project. So they have knowledge, they already have done tests in some kind of way. And the question is, how can we use this kind of information which is available and make it also available for consumers? So this will be a question for the future because this will enable us to reduce this cost of the testing somehow. Yeah. So the question would be, what kind of standards will we use in the future to provide this information in a comparable and understandable way? So this is my finishing of the talk, and thank you for attention. And also thank you to the team to make these results happen. And if you have any questions, ask it now or later. You can identify us here with this red symbol. You will find us here in the audience, and later during the break, either ask me here or later the team. Okay, thank you.